Yo, what the fuck?
Big brain.
That is a wonderful trick.
You ever wonder why you're still using graphs? Yes? No? It really doesn't matter. You don't have a choice. Or maybe you're telling yourself, ooh, to solve another function, I am sick of this. I have been doing it for way too long, and this honestly is terrible. Well, don't worry, we're all thinking the same thing. So instead of transforming regular functions, we're going to be transforming exponential functions. Is it easy? Is it fun? But yeah, it's speedrun time. Today we're going to be working on transforming exponential functions. We've been given another problem to solve. Thanks to Mr. Muff. It's kind of like the last unit where we were just transforming functions, but they're exponential now. But anyways, what we're gonna be doing is we're gonna be transforming this right here, okay? This is a function. How do we know it's a function? Because this f of x. It only means that it's a function, okay? It works. It works. And we have 3 with x plus 2 over, yeah, basically. And so what we need to do is we need it to be translated 6 units to the left, vertically stretched by a factor of 2, and then reflected across the y-axis. I thought that said x for a minute. Right. Right. About transforming exponential functions. They're really like the last unit, but there are a couple of things we should know. Like our domain. What is our domain? What is our range? Even though that's not necessarily like what we're being asked. And then we'll talk about our asymptote. What is that? It's the line that never, it never touches the actual number. It never equals 0 right here. So you see how it's like kind of on a line? If you zoom in, it's not on any of these lines actually. See, we never really hit that. It's gonna be approaching it, but it doesn't. It shoots straight up into the air. So it really never touches the number, or at least for here. But the range is going to be the value it touches in y. So, y equals this, right? And usually the range is a set of real numbers greater than 0. Anything above this is, that will be the range. Let me just zoom out enough. This is good. Yes, this is good. And then we have our domain. Domaining. Yeah, that's gonna be all real numbers. We have a saying for that. It's called darn. Darn is all real numbers. That's what your domain is. Make sure you remember that, okay? Make sure you remember that. But anyways, let's move into what we were actually supposed to be doing before I went ahead and did all of this. So, if you remember what we talked about in there we go. In transforming functions, we kind of had a little rule of thumb with how we wanted to approach transforming them. It was kind of like 1, 3, and then 2, or the middle, the left side, and then the right. We could do that. We could certainly do that, but we're not going to do that. We're actually gonna go about it how it's written right here, because this is easy. So let's start working on translating this 6 units to the left. What do we know about translating 6 units to the left? Well, if you watched the last video, and thankfully you may have, at translating 6 units to the left usually means we're going to be adding. As you can see right here, our little line right here, this nice curve, it's on the left side. Like, if we're speaking, like, is it crossing 0? No. It's more so in this left region right here, not in this right. And that would be adding. Okay, you see this plus sign right here? That means we're going to the left. Now, if it was a minus sign, let's change it like this. Then we're moving over to the right. Plus is moving to the left. And subtracting is moving to the right. So, let's get an example of that. This is a perfect example. Translating left, right. See, we have g of x equals f, and then x plus k, which would kind of look like this in an example. So, as you can see here, they're moving 5 units to the left for here, but instead we're trying to move 6. So it's simply just replacing it with a 6, okay? We're adding on this 6. We want to move 6 units to the left. So we do that. Easy peasy. Now, let's look back here. We want to stretch. We want it to be stretched vertically by a factor of 2. Check out this side. Stretching and compressing. Now, we already know we're going to stretch and compress vertically. Thankfully, that was given to us. And what do we do here? Well, let's read these bulletins. This also is my board. I completely made this. I borrowed it. Borrowed without permission. But with every intention of bringing it back. So, right, we're going to be multiplying the entire function by k when we stretch / compress vertically. This time we're going to be stretching. And so, this one right here. So, let's read through this. Now, so, if k, so we have the function y equals x times bx. So essentially multiplying the entire function by k. If k is bigger than 1, it is a vertical stretch. If k is between 0 and 1, it is a vertical compression. Now, we're not working with a vertical compression because, well, we've already been told we're not working with a vertical compression. We're working with a vertical stretch, so it is gonna be bigger than 1. Now, right here, this is important. Stretching / compressing by a factor of k. What do you see right here? Okay, let's look at this. By a factor of k. So essentially, k is going to be our factor. And how this clicks together is that we've kind of already been given this. Stretched by a factor of 2. K is going to be 2, which is bigger than 1. So that makes sense. And we're going to multiply this by the entire function. So let's go back here. And just like in this format, we're actually going to scroll down. There we go. This is how this would technically look. Stretch / compress vertically, and this is the example we're given. 5 times 2x raised to the power of x at least. So, instead of writing just 2 times, that's not gonna work. Yeah, no. I mean, you could, but no. That's not how we write it at all. That's also not going to work. It would be this to, there we go. So this would be your vertical stretch by a factor of 2. Multiplying the entire function by 2 right here is then be reflected across the y-axis. The y-axis, this going up and down is the y-axis. Over here is going to be the x-axis. So we're not necessarily going left. We're not going this way and this way. This way. We're going this way and this way. Okay, so it's kind of going to go like this. So we also have another page for that I totally did not steal. Reflection across the y-axis. Multiply the x by 1. -1, sorry. So essentially, moving that minus sign. So if it was x, the x-axis, a reflection across the x-axis, and we were multiplying the function by -1, the negative sign would go in front of this little 3. But we're not doing that. Instead, the negative sign is going to go in front of our x. What is our x? Our x is this. So essentially, this is what this equation, or no, this function, okay, fancy word, this is what this function would look like if it was moved over 6 units to the left and then also vertically stretched across by a factor of 2, and then also over the y-axis. I don't know why I butchered that so badly. So, yeah, it's pretty simple, and also kind of straightforward, just like how we were transforming functions. I may have lied about it being hard. It's not so bad when you have the formula sheet.